In this series of videos, we're going to talk about the graph of a function. So in this first problem, we've got y equals x squared minus 1. If we're not sure what this graph looks like, we're going to make a table of values. And we're going to put values in, choose maybe a couple of negative values, maybe 2 or 3 negative values, 0, and then some positive values. Now I'm going to make a pretty large table this way I can get as many points as possible on my graph. When I put a negative 3 into the equation for x, y equals x squared minus 1, negative 3 squared is 9. 9 minus 1 is going to give us an 8 for an output. When we put negative 2 in, negative 2 squared is 4. 4 minus 1 is 3. Negative 1 squared is 1. 1 minus 1 is 0. When we put a 0 in, we're going to get negative 1 out. When we put 1 in, we'll get a 0 out. 2 gives us 2 squared minus 1 is 3. And then 3 gives us 9 minus 1, which is 8. So negative 3, 8. We'll plot that point. Negative 2, 3. Negative 1, 0. 0, negative 1. 1, 0. 2, 3. And 3, 8. We connect the dots as nicely as possible. I'm going to try and make this a little bit more smooth because it really is a smooth curve right there. And that's what our graph looks like. You can see that this graph is symmetrical about the y-axis. So there's a couple things that we can see here. We've got some symmetry happening about the y-axis. We also can tell that it's a function, and it's a function because our domain, you can see that our domain is going to go from left to right forever. So we go to the left, and then we go up, and then we go to the left, and we go up, we go to the left, up. So this is going to continue forever to the left, and then the same is going to happen to the right. We can continue to go to the right forever. There's absolutely no restrictions on our domain because we don't have a denominator. We don't have a radical. Therefore, we have no problem. So our domain goes from left to right forever, and each x input gives us exactly one output. So it is a function, and its domain is all real numbers. We can tell by looking at that equation right there. No denominator, no radical, no problem. And the range, if we look closely at our range is our outputs, and our range starts at negative 1, and it continues forever up to positive infinity. So negative 1 to positive infinity. And negative 1 is included as an output. And then every output, for every y value, there is an output. See, that's continuous right there. For every input, there is an output that, for every y output is continuous from negative 1 to infinity. Okay, so we checked for symmetry, and we know that this has y-axis symmetry. Definitely has y-axis symmetry. Does it have x-axis symmetry? Graphically is how I would look at this, and no, this does not have x-axis symmetry, nor does it have symmetry with respect to the origin. We can test that algebraically using our equation as well. Now, the intercepts. Let's talk about the intercepts. The x-intercept is the value of x when y is 0. And the y-intercept is the value of y when x is 0. So let's compute the x-intercepts first. I can see them right here, so visually I know what they are, but I'm going to confirm algebraically. So the value of x when y is 0. So we have 0 equals x squared minus 1. We add 1 to both sides. We're going to use the square root method. When we do that, we get plus or minus 1. Therefore, our x-intercept is negative 1, 0 and positive 1, 0. Very important. I would highlight this. Always, always, always write your intercepts as ordered pairs. If you do not write your intercepts as ordered pairs, it will be considered incorrect. We want to be correct. Okay, the y-intercept is the value of y when x is 0. So y equals 0 squared minus 1. Y equals negative 1. And indeed, you can see on our graph that that is the y-intercept, 0, negative 1. So it's the location as an ordered pair. So that's something that we know. We've done tables a long time ago, maybe in 8th or 9th grade, algebra class. Our function, the domain and the range. We've talked about symmetry. Now we're putting it all together in one problem. So here's number 2. Here's one for you to try. So you go ahead and try this one. It looks like it's a little bit more complicated, but it really isn't. When you create your table, you should just have a little bit more arithmetic to do, but nothing that isn't doable. Okay, so press pause and see how far you can get. And when you want to check, press play and see how I'm doing the math. Okay, so I'm going to create a table, and I'm going to take a guess and say, let's put in a negative 2, a negative 1, a 0, 1, and 2. If I put a negative 2 into the function, negative 2 minus 3 is negative 5, and negative 5 squared is 25. So the opposite of 25 plus 5, that's negative 20. That's probably not going to work. Let's put a negative 1 in. So we're going to try negative 1. We put negative 1 in, and we get negative 1 minus 3 is negative 4 squared is 16. The opposite of 16 plus 5 is negative 11. I'll put it down there even though it's a little bit off the graph. We're going to plot it. See, sometimes when it's just slightly off the graph, it's okay. So we put a 0 in, and we've got the opposite of 0 minus 3. And 0 minus 3 is negative 3. Negative 3 squared is 9. Negative 9 plus 5 is negative 4. So we'll put a 0, negative 4 in. And then we put a 1 in. And 1 minus 3 is negative 2. And negative 2 squared is 4. So negative 4 plus 5 is 1. So 1, 1. Oops. 1, 1 right there. And then we'll put a 2 in. And 2 minus 3 is negative 1. And negative 1 squared is 1. So negative opposite of 1 plus 5 is 4. So 2, 4. Then we're going to put a 3 in. We really want to see this. It looks like it's doing this, right? So I really would like to see it turn. So we'll see when this is going to turn. So we'll put a 3 in. 3 minus 3 is 0. Love that. 0 squared is 0. So that's going to give us a 5 out. So 3, 5. There's a 3 and a 5 in that equation. It's interesting. Then we'll put a 4 in. So we've got 4 minus 3 is 1. 1 squared is 1. So we've got 4, 4. Okay, so look, it looks like we might, if I put a 5 in, I wonder if I'm going to go back this way and get a 1 out. So let's try that. We put a 5 in, and 5 minus 3 is 2. 2 squared is 4. Negative 4 plus 5 is 1. So 5, 1. We definitely have some symmetry going on. If we put a 6 in, 6 minus 3 is 3. 3 squared is 9. So that's a negative 4. So you put a 6 in and we get a negative 4 out. And then I bet if we put a 7 in, we're going to get a negative 11 out. And we are. 7 minus 3 is 4. 4 squared is 16. And that gives us a negative 11. So it's a target. And there's our beautiful graph. I'm going to just make this a little bit thinner so I can draw a little bit. There we go. There. So we do have some symmetry going on, but we don't have any symmetry with the x-axis. That's a no. And the symmetry is not with the y-axis. See, we don't fold on the y-axis and land on itself, so that's a no. And we don't have symmetry with respect to the origin. Whatever's in this quadrant would be in this quadrant. You know, a mirror image across that origin, that's a no. So the x-axis, y-axis, and origin symmetry is no bueno. Is it a function? Is it a function? It is indeed a function. Another way to check to see if we have a function is using what we call the vertical line test. So visually, we can see if we have a function by taking this vertical line and passing it through the graph. And as long as it doesn't pass through the graph and intersect it in two locations at the same time, like right now, it's only passing through the gray graph once. It doesn't fail. It passes the vertical line test. So it passes through the graph and only intersects it one time at any given point throughout the graph. So there you go. It is a function. So yes, this is a function. And the domain, we can look right here. No denominator, no radical, no problem. So our domain is all real numbers. And the range this time going from least to greatest. You always go least to greatest. So the least is negative infinity. And the greatest value it will be is a 5. So negative infinity to 5. And it includes 5 as an output, therefore 5 is a closed interval. And now, what are the intercepts? This is going to be a little tricky because it looks like there's an intercept right there, an x-intercept right there, and a y-intercept right here. I believe the y-intercept, right, is going to happen when x is 0. So there we go. We already found that. That's 0, negative 4. Let's try and find those x-intercepts. So these are the x-intercepts right here. So we've got y equals the opposite of x minus 3 squared plus 5. We're going to put a 0 in for y. And then we'll solve for x. So we subtract 5 from both sides. We get negative 5 equals negative, or the opposite, of x minus 3 quantity squared. I'm going to divide both sides by a negative. And then I am going to square root both sides. When we square root both sides, we get a plus or minus the square root of 5. So plus or minus the square root of 5 equals x minus 3. We're going to add 3 to both sides, which gives us x equals 3 plus or minus the square root of 5. So our x-intercept is 3 plus the square root of 5, comma 0. And the other one is, I'm going to erase this, the other one is 3 minus the square root of 5, comma 0. Now the square root of 5, I want to say that the square root of 5 is about 2.2-ish. You go to your calculator and you can confirm that it is 2.2-ish. So 3 plus 2.2 would be about 5.2. So 5.2 comma 0, and 3 minus 2.2 is 0.8, so that would be 0.8 comma 0. So this one is 5.2 comma 0 as a decimal, and the other one is 0.8 comma 0. And there is graphing of a function. Graphing of a function. We're going to, in the next video, we're going to take a look at these three. So you might want to pause your video right here. Actually, we're going to come back in the next video, and I'll give you time in the next video to draw these graphs onto your paper.